let's have our folks understand, what are we dealing with here? Is this your first B-Sides? Show of hands? In the back there, a couple here. Cool. Would you say 50% maybe?
Yeah.
Like half, roughly? Yeah. Well, thank you for being here.
Welcome to B-Sides.
Yeah. All right. With that, we've got Mike Shema, Secure Designs, UX Dragons, Vulnerability Dungeons, Application Security Weekly podcast. Mike, thank you for being here. Please take it away with the team. Thank you.
Thank you. Hello, protocols, packets, programs, and B-Sides San Francisco. This theater has several exits. In the event of an emergency, just keep shifting left until you find one. At the end of the session, please be considerate for the next one and pick up any CVEs that may have dropped. Garbage bins are provided in the hallway. Which means today we explore some secure designs, avoid some UX dragons, and throw some Vulns into dungeons. Grab some dice and stay tuned for Application Security Weekly, because this is episode 328, recorded live here at BSidesSF on April 26, 2025. Let's have a round of applause. Yes. I'm your host and Dungeon Master, Mike Shema. I'm here with Kalyani Pawar. Kalyani is a seasoned AppSec expert with a deep passion for the startup ecosystem. She has extensive experience in designing security programs for startups from the ground up and advises early-stage AppSec startups on their products. Hello, Kalyani. Thank you for joining us.
Hello, everyone.
And we have Jack Cable. Jack is a hacker who works at the intersection of cybersecurity and public policy. He's currently the CEO and co-founder of Corridor, and before that served as a senior technical advisor at CISA, where he helped lead their initiative on, quite helpful for us, secure design. Hello, Jack. Thanks for joining us.
Hello. Thanks for having me.
Now, I do want to take a moment to set the premise for this adventure. If you ever want to see a group of players demonstrate the nuanced thinking of threat modeling, have them encounter a door in a dungeon. Give them one minor detail, like a little bit of rust is visible on the lock, or there are 3 small scratches on the floor. Then watch as analysis paralysis sets in and they deliberate on how dangerous the door might be. Sadly, that also typically grinds the game to a halt. In the world of AppSec, we don't want to be stuck in eternal threat modeling either. We have to have some sense of when a secure design is secure enough. And we want those designs to have a UX that doesn't bite us and vuln classes that don't bother us. It's like condensing 4-question threat modeling into, are you really sure? So let's open that door. We're going to need a map as we explore, or at least some blank paper to draw that map on. So let's grab some A4 size paper to go along with our OWASP A4 entry on insecure design. Coincidentally, the paper sizes follow this cool rule where each number halves the larger dimension of its predecessor. So if the top 10 list were to follow that rule, being 4th would make insecure design 1/8 the size of broken access controls, which is kind of sad because it's first in my heart. I also mention that because AppSec still struggles with metrics and quantification. Like, what does more secure even mean? That OWASP entry, for example, gives us a weird amount of decimal points for CVS averages. It's a bit of precision theater. I don't think we care about the tenths of a CVSS score, let alone hundredths of one, but we do care, or at least I care a lot, about dragons, or at least UX dragons. One of my favorite formulations of this problem comes from the 1999 review of PGP's usability in the famous paper, Why Johnny Can't Encrypt. Now, to put 1999 in context, that was the year that the Blair Witch Project and The Matrix came out in a theater, much like this one. By the way, both movies were about a small group of people who find themselves in a horrible situation due to 2 very different problems related to batteries. But back to the paper. It highlighted the importance of helping people avoid dangerous situations, which holds true for horror movies, D&D, and of course, AppSec. But if we look at this through the lens of secure design, part of the problem becomes, how did this design fail the user? And that's on top of figuring out an end state like, what is secure enough, or what does more secure even mean? So obviously, we want secure designs, but I wanted to talk explicitly about security that protects users and to help figure out when we might reach one of those end states. So that 4-question threat model already touches on what can go wrong. So it's not like this is a huge difference, but my framing is, how do we prevent dangerous errors? So let's talk about those errors, who makes them, why they happen, and why blaming users is a very lazy AppSec mistake. Because dragons, dungeons, and errors are all dangerous. So Jack, like any horror movie or adventure, we should start off on a happy note. What's an example of a secure design principle or example that's a favorite one of yours?
So a couple thoughts here. And first of all, thanks so much for having us here. One of my favorite topics to discuss. So I got added to this panel a couple days ago and was more than happy to join on. For me, a lot of this comes back to the work we were laying out at CISA, where we published in 2023, so just about 2 years ago now, our initial Secure by Design white paper, and did this with a coalition of 13 other countries, their cybersecurity authorities, and in that really laid out 3 Secure by Design principles. And I'll draw on one in particular, which is leading with radical transparency and accountability, where really what we recognized was that at the end of the day, a lot of these aspects of Secure by Design, while they're grounded in technical elements, a lot of the challenges aren't technical, they're organizational. The reason that, say, Johnny can't encrypt, that we end up with these bad UXs is often that just this isn't a consideration that goes into building a product. It's not that we don't know how to build a relatively secure product. It's just is that organizations to date don't prioritize it. So how do we get there? Well, that starts with having a really solid understanding of what does and doesn't work when it comes to building secure products. And that's why when I was at CISA, we were so forthcoming in really calling on tech companies to be transparent about their security. So last year we launched the Secure by Design pledge, coming up on just about a year, which now 300 companies have committed to, not just taking actions to improve their product security, but demonstrating that progress. And as we come up on the anniversary, we see that a number, not all of the companies who commit to doing this, but a number have documented the approaches they've taken, and glad to dive into some of those examples. But just to really set the stage, I'd say that there is a need for companies to be more forthcoming with what they're doing here, both positive and negative success stories, because at the end of the day, that's how we get better.
Yeah, I think that the theme there too is, I led with, let's not blame the user. It's also, let's not necessarily blame the company either if they're making that good faith attempt on accountability, transparency.
Exactly.
Kalyani, give us a favorite principle or example of yours.
I'm going to go with 2. So being the startup representative on this panel, I want to say at startups, we don't have time to build everything all the time securely, right? For example, if we're going to go have cloud infrastructure, are we going to go build our own clouds? No, right? We just go to AWS or Azure and then build off of it. Why do the same for security, right? Obviously, you want to do the same thing for security. And so don't build your own cryptographic algorithm. Use secure frameworks from the get-go. So yeah, use secure defaults. That's my always, forever favorite. And the second one most applicable to the ecosystem would be, it sounds basic, but it's so applicable. It's principle of least privilege. I feel like having been at startups, I've seen everyone have had admin access, especially in the early days, in the seed days. And damn, everybody gets upset when you take that away from them. So yeah, those are my 2 favorites.
Yeah, nobody's happy when you take something away, which is one of those challenges of secure defaults. Maybe let's talk about that a little bit too, because secure defaults are also one of the most consequential things you can do as an org to protect your users. I'll go back to 2 examples, maybe Log4j and XML. Log4j, everybody was scrambling to patch a bug in a feature that nobody really needed or was even using. So why was it even there by default? That's one of those shake your fist at the sky. And even with XML, if you look at XXCs, it's kind of a surprise that my app is going to read from the file system, even though all I needed was a couple of, okay, I'm not a fan of XML, but the format is at least, a little bit human readable, but you just need that file. It doesn't need to call anything where else. And I don't know, Jack, is this, when you look at designs or just these secure defaults, how do you balance that discussion of, well, let's turn this on or turn this off and figure out who we're making happy, who are we making sad in that balance?
So I think I'd say, first of all, to some of the discussion here, it's much easier to build a product that is secure by default from the start, rather than shipping an insecure feature and then over time realizing, hey, we got to turn this off. And then suddenly you have a whole bunch of customers who will be really disappointed because that's ingrained in their workflows. And that there's just lots of kind of technical work to then overcome and make something into a default. Just to give one example, so I got into security through bug bounty programs, did a bunch of those. And one example that came up again and again is that in AWS, when you configure your EC2 server, for instance, there's by default, at least there was, this metadata server that had this wonderful property that if you visited it from an EC2 server, it would return things like the access credentials for that instance, which sounds okay in theory because sometimes you'll need to access that. But then it turns a vulnerability like server-side request forgery that by default, you can access some stuff, but turns that into essentially full control over an AWS environment. So that's the sort of feature where when they were deploying that, I'm sure they didn't think about, oh, well, this is going to allow everyone to basically get their AWS accounts fully hacked. And it's taken AWS the better part of, 5+ years to move towards a more secure default. And you still have all these instances that are relying on that old metadata server in order to function properly. So they can't just break that. They have to slowly improve when new servers are created, for instance. So again, it's much, much easier. And if you're out there, say, building a new product or a new feature today, think about the both security implications that an insecure default would have, but also when the time does come to try to turn that into more secure default, you'll really be wishing that you had done it the secure way from the start.
Yeah.
Another time you would wish it if you were losing out on sales, big time. Like I have seen certain companies lose out on sales just because they could not pass the vendor security reviews. And yeah, so instead of like last minute scrambling for building secure infrastructure, why don't we bake this in the first place?
And part of that too is, and me, I'll go to you, Kalyani, for this as well, is that, Jack made that point. IMDS v2 came out, it's secure. Hey, we don't have to even worry about SSRF anymore. But Amazon can't just roll that out for all their customers on v2. That forced migration would break tons of things, and a lot of people would be unhappy. So if we talk about then the burden on the team, especially like a small startup team, how do you figure out to say, this is the time we're going to spend on dealing with someone else's insecure default, and we want to make our own defaults ourselves better?
I think it's a debate, right? It's a patch versus rebuild debate, if I can put it that way. If it's small but high impact, if it's maybe a couple PRs and then it's fixable, let's do it. Let's patch it right away. But if it is like a deep workflow dealing with like authenticating your payment structure or something like that, I'd rather have the rebuild approach. It's going to be deep, but I think it's going to reap the benefits long term. There's also another angle to this. We often talk about the buy versus build, but at startups, you don't have the liberty to go buy at whim. So yeah, rebuild.
Yeah, I'm going to rebuild, and I'm going to riff on that because we could also say, well, what if we just rewrite it or write everything in Rust from the beginning? And maybe that's, engineering hat is on, that fixed everything. I don't think that's the case because, Jack, one of the things that you kind of alluded to when you're using that AWS example is that it took several years for IMDS v2 to come out, to be available. It sounds like really easy to say, just flip it so CSRF isn't there by default. What are speaking of like org accountability, radical transparency, what are the other types of org frictions that make that secure design hard?
Yeah. So a couple of thoughts here. I'd say that one, really getting back to the CISA principles, where this is something that needs to be ingrained in how an organization operates, not just at the technical level, and not just, say, CISA as an organization, but needs to really be coming from the chief executive officer all the way down to prioritize security. Because as we know, it's a lot easier to build a product that is relatively secure from the start than go to try to retrofit a product to be more secure. I left CISA a couple months ago. I've been working on a startup where we're working with companies who have lots of legacy technical technical debt, and we're working to help them mature their application security capabilities in order to root out classes of vulnerabilities. And really, to a point that was made earlier, right? We are in a fortunate position where we're not perfect now, but there's proven examples of secure defaults and secure behavior where, and a lot of this gets into, for instance, various frameworks that are out there where cross-site scripting used to be something that you would really have to think about and figure out, okay, how am I going to make my application resilient to these vulnerabilities? Now you can use React, which developers prefer anyways, because it makes it easier to build out a product, and unless you do something dumb, you're going to be secure. Or likewise for database queries, where unless you want to be handwriting your own SQL queries, there's libraries out there that will make developers' lives easier and also have the side effect of improving security. So I'd say for companies out there, it's figuring out, okay, what are these guardrails for each class of vulnerabilities that will take, where possible, using these existing frameworks. And really then it does become easier for new products, at least, to build those out with secure defaults.
Yeah, the React is one of my favorite go-to examples. I definitely want to give up the big +1 for that because it also came out of an engineering effort. This was a team that wanted to more easily create front-end UIs. And oh, by the way, we're going to add that dangerously set inner HTML is the only way to introduce, XSS in there. But we also, I'll say the counterpoint to the statement there about the SQL is that I think it was easily back to 2004, 2005, MySQL had prepared statements available. It had that available in PHP. I think it was PHP 4 even introduced it. And today we could probably look at this year, probably at least, I'm going to guess 200 CVEs related to WordPress PHP SQL errors. So there's got to be some failure along the way there. I'm going to posit maybe it's API, let's go back to that usability as developers of the users of these. How does that influence whether or not this, our React example is probably good, but our prepared statements, it feels like we're still failing there.
Yeah, I mean, I'd say that the tools are there to build more secure applications. But again, at the end of the day, are companies going to make use of those tools? Are they going to prioritize security from the start, or are they going to do what many companies do and rely on the fact that as of today, for the vast majority of products, they outsource the risk for their weaknesses. So when a product gets breached, it's their users, it's their customers that really have to pay the cost. And as a result, we see companies continuing to under-prioritize this. So I think we can do more to both make it so that the default route when you're building an application is the secure one, but also we should be thinking about how we shift some of those incentives so that companies are more, especially financially motivated to prioritize security from the start.
Yeah, Kalyani, where do you see that incentive coming from? Because on the one hand, the CISO is like, well, I can say, it doesn't take too long to write that blog post that starts, we take your security seriously. It takes a little bit more budget to invest in security from the start. How do you get that? How do you make that convincing?
I think, well, again, it depends on what the product is, right? Like if it is something that is directly interfacing a consumer, an everyday consumer, and if there's anything that's jeopardizing their privacy, their PIIs, obviously it's easy to make a case for something like that. But I think if it very much boils down to what is at stake here. What is the price that we're going to pay in terms of, say, PR, business, finance? What is the price we're going to pay? I think once you can analyze that impact better, again, it's a very subjective answer with respect to what your product is.
Yeah, and I think it's interesting how you framed it that way, because my wish is that how do we prevent those dangerous errors that the users make? And even that back to the, why Johnny can't encrypt, how can we have a better UI so users are led away from mistakes, or they're called to attention of what mistakes they are, as opposed to protecting the company? Now, I don't think you're necessarily wrong in saying that. That's a very, it might be cynical, but I think it's a realistic type of approach.
Yeah.
But maybe the question for both of you, and I'll start with Jack, is that how do we introduce, how have you seen that the UX type of questions as part of threat modeling? Like, how is the user going to be hurt by this?
Yep. So I think that that's an aspect where, again, really a core part to building secure by design applications isn't just making sure that in isolation, in kind of the ideal state, the application can be secured, but making sure that the default experience when users get the product, it's out of the box secure. So you can have the most secure product ever that's super resilient, but if you ship it with a default password and put in the manual, hey, you really ought to change this password, we know that the vast majority of users just aren't going to follow that. And it seems like a silly example, and yet we are still having critical CVEs that are being used by state-sponsored actors exploiting vulnerabilities like default passwords. So it can be these really simple examples where, again, it's not that we can't deliver a product without default passwords. It's not that we can't deliver a product that has certain ports disabled by default, but it's just that it's become the status quo where, again, companies will often prioritize, say, backwards compatibility rather than some of these forward-looking security implications. That's an aspect we addressed in the white paper at CISA as well. So really, what this comes down to is doing these kind of evaluations in the wild. We were talking about before the show. There's a really good example by Thinkst Canneries where they realized that they had in their documentation essentially configure a DNS record with like yourcompanyname.com, and they've realized that about 40% of users literally copied that and created a DNS record for yourcompanyname.com, which in turn defeated some of the security properties. So it's things like that you can only really see by applying some of these same UX principles that are used to make usable products. They also need to be applied for security.
I'm going to go back in history a little bit here and then give the Citibank example, right? The Citibank UX error, which enabled someone to wire $500 million, right? I mean, what is coming back to like, what is the risk here? Isn't it a huge risk? Had this not, had this gone a whole threat modeling phase, we wouldn't have been here.
Yeah,
right?
and that was just from a very bad UI. That wasn't even that wasn't even part of a dedicated security tool.
Yeah.
For example, it's just a UI mistake. And so I'm curious then maybe to part of what Jack's emphasis is, it actually can be better, easier to secure secure by default. And Kalyani, in the startup world, you often have a green field. So one of my questions there is like, I love a design principles behind something like WebAssembly, WASM, has all these wonderful isolation. You can't get to the file system by default. You can't get even to the network by default, which seems good. That's similar to like, we could say there's a corollary there with Kubernetes or with the cloud. How much of these are just, you have a secure default environment you're building your app in versus you need to be focusing on what are the problems of your app that you're building? Does those distinctions come up?
I think something that we're trying to touch in both of these cases is this app something that only experts can use? You know what I mean? Like, if only an expert can enable these things, then the app is not useful for anything. And if we're implementing security in such a way that only experts can use it, you're not making it easier for anyone to use it. I think that's a debate. Yeah, well, I think in startups, it's easier to get that answer because you have very clear-cut priorities. That's just what startup culture is. You know how fast-paced it is. You know exactly what is on your roadmap. And I think it's easier to get to those answers rather than being like, how many more obstacles can I place before implementing this certain feature in an application? Yeah.
So maybe let's turn that to then that idea of when is the design secure? What's secure enough? And I like the paper from CISA. That's one of the reasons we have you here. And they even made that call out to considering the user experience, do the field testing. But there's nothing around quantifying when are you secure? Is there a number? Why isn't there any quantification, Jack?
So I'd say part of this is, and I fully agree that we do need to better quantify here. that we need better ways of measuring at the end of the day security outcomes and not just effort, because you can put all the effort you want into securing your product. You can go through SOC 2 and all these compliance regimes, but then at the day they often say very little about the actual product security steps that were taken. So I think the current state is there's a lot of companies out there who think they're doing a really good job of securing their product because they follow all these checklists, they are putting in a lot of effort, but then that doesn't always correlate to actual results. So I agree that there needs to be a more outcome-based approach here. There also needs to be more ways of measuring a product security. One of the last things I worked on at CISA was a document called Product Security Bad Practices, essentially a list of 13 items to say, hey, you really shouldn't be doing these things in 2025 when building security products or when building software products. And we got a little spicy. We called out things like using memory unsafe programming languages as a bad practice, because the reality is that if you're building a product in 2025, there's languages like Rust that are as performant and interoperable that can be used, and that C, C++ are just inherently insecure. You can't build a secure product, I believe, if you write in C and C++, because even the best developers can make mistakes, and there aren't guardrails around that. So I think this really calls for companies to begin to actually measure the security outcomes of their products and not just the effort put in to make the product secure.
And I think that ties into that transparency you started with, because if the companies aren't being transparent about both here is a security problem, but here is what we did about it, here is the postmortem, then we're not getting that information about how to learn from those bad practices, right?
Yeah, exactly.
Yeah. Kalyani, there's an aspect here of, I mentioned too, jokingly, rewrite everything in Rust. You can't quite do that. We could also, I'll be snarky and say, well, we could rewrite everything in PHP so it's memory safe, but possibly we still have some problems there. Is programming language like the decision point for startups? What are they thinking of when they're like, we need a product, we need it to be secure? What are some of the principles that they're either should be avoiding? We'll come back to Jack for some more examples, or like a principle that they should continue to embrace.
I think when we're talking about like programming languages in terms of startups, I think it's always what will get us faster to that point. It's more so a conversation where it's like, okay, if Python is going to help us ship this thing faster and all of us are comfortable, coding in Python and making the application in Python, then it's easier for the security team to build frameworks or build guardrails in place once we know what our like the baseline cookie dough looks like. But that's how I would like to look at it. I would like to think about this from more of a finance perspective. Like what are we trying to get here? Because we're strapped for cash. We need to prove ourselves out there. We're on a deadline. If this answer is going to help us ship fast and meet all our goals, then we will think about security on that.
Well, and Rust, to be fair, is going to be performant. It's going to be stable. It's going to have code quality, which security is part of quality. So that probably is a pretty good practice. Don't use a memory unsafe language. What else showed up on that bad practices list that you'd like to highlight?
Yeah, so a number of other areas, some of which we've touched on today. So things like SQL injection. There's no reason that you should be handwriting your SQL queries in this day and age. Similarly for vulnerabilities like command injections, where, again, raw user input should not be supplied to an operating system command, and yet we see vulnerability after vulnerability really. Those three, SQL injections, command injections, memory safety vulnerabilities, dominate the list of, say, CISA's known exploited vulnerabilities. So I would say that really where this is going is, and where we see some of the leading companies working, is blending a lot of these ideas we've talked about and thinking about developer experience, where it's not just what is the experience for your end users, but how are developers either encouraged or not encouraged to follow secure defaults. And companies like Google, for instance, have written extensively on how they've made the secure development route for their developer, or the default route for their developers, to be a secure one, where they just can't introduce user input into database queries because they have specific types that don't allow user input to be supplied, and so on for cross-site scripting and other examples. So that really, I'd say, is a area where the security community needs to be thinking about not just how can we make something that in isolation can be secure, but how can this be adaptable and used in ways that React, for instance, I think is a very positive case study. There's others, Let's Encrypt, for instance, where we now almost take for granted that the fact that the vast majority of internet traffic is secure. A decade ago, that certainly wasn't the case. So we have many positive examples here, and the more we as a security community can advocate for the default route for software development to be a secure one, the better. And again, security doesn't have to be the primary motivation. The primary motivation might be quality, might be speed, but if security can be a side effect, then we all win.
Yeah, I love the Let's Encrypt example, because for me, there was the ancient age of what happens if your certificate is compromised, especially, or leaked, et cetera, especially when you have 2-year or even 5-year certificate lifetimes. So we had CRLs, then we had OCSP that was trying to fix some of the problems, design problems of CRLs. But OCSP introduced some additional privacy concerns, and it didn't actually, it fixed a bad design of CRLs, but it didn't fix the bad design of what happens if you have an attacker in the middle, an intermediation. Whereas Let's Encrypt now, we almost don't need these examples because we can get down to 6-day certificate lifetimes. That's a great, that's a great progress. You also mentioned Google as one example amongst others of having the humans write code and avoid a lot of problems. Let's make this a little more complex and say humans aren't the only one writing code anymore. We have something, MCP, agents, Gen AI. What happens when the LLMs are starting to write code? Are they introducing, new problems, different problems? How does this become the secure design challenge?
So a couple of trends, I'd say. So as I'm sure people are closely following, right, we're quickly moving towards a future where there's a few trends. One, there's going to be a significantly higher amount of code being written. We're seeing this already as people are going to use Cursor or some of these other AI assistants to write their code. They're able to deliver products much quicker. And not only that, but it's really expanding the remit of who can write and publish code, where it's not just software developers who can write code, but can be hobbyists or product managers or designers, really anyone who wants to turn something into an application. Again, might not be a great or fully functional or fully secure application, but they certainly can do a lot more than they were able to do before. And then the third trend is really that with all this more code, with more people writing it, there's going to be fewer and fewer eyes on code as it's written. Really some of what I've been focusing on now with Corridor is thinking about how can we make sure that as more code is being written, as there's fewer eyes on it, as the security tools of today just won't be able to keep up with that, thinking about, for instance, the UX of security tools, which I'd argue there's a lot of crappy security products out there today. And if you have 10 times more code, what does that mean for the developer who has to go through their alerts one by one and figure that out? A lot more of their time, as of right now, will be eaten up by these noisy alerts. So figuring out how can we make a more seamless system where the secure route, for instance, as code is being developed, is the default one. And that's really where we think we have to move towards this model where, again, it's not something that you have to be thinking about necessarily. Not every developer is going to know even what security properties their application has to have. But moving towards a future where, as these AI assistants are helping write code, that they can output code that's more secure by design.
I definitely want to add one more thing to it, though. As we're moving so fast towards like all these new tools and we hear all these new terms every day, I feel like the core principle of security still remains the same no matter how many iterations of toolings we go through, right? I think if you do follow your secure design principles, your secure design practices, your basic input validation and threat modeling and things like that, the possibility of having really insecure design or insecure code, I think that lowers. It brings us back to the very principle of, are we baking in security since day one?
Yep.
Yeah.
Yeah, and I mean, MCP is sort of is self-described as the USB-C of the Gen AI world, but since I've been making all the 90s and early 2000 references, it's also the SOAP and the WSDL of the Gen AI world. We've been there, done that, and the reason I bring that up is to Kalyani's point. Why do we already have all these MCPs, and our calculator app can read from the file system? I thought we saw this and we learned from Android and iOS building their walled gardens. Admittedly, there are trade-offs here, but constraining what these apps can do. And Kalyani just pointed out that suddenly now all the Gen AI LLMs are right back to insecure designs that ostensibly we should have learned from better. So that's more of a comment than a question. I'm not sure how to I'm going to have to hand this off to you, Jack.
Yeah. I mean, and I would say that that's exactly right too. That both the upside and the downside is that AI isn't fundamentally changing, that we do know how to build relatively secure applications. We know how to root out common classes of vulnerabilities. But the reality is that unless a company is taking an active approach, the default is that AI-generated code is going to introduce more of the same old vulnerabilities that we've known about for decades and have also known how to prevent at scale for decades. So it's an area where companies need to be actively thinking about how are they both applying these secure guardrails and doing so in a way that will scale to however the code is being written.
And there's a trap here, though. And for example, with MCPs, I like the idea of adopting OAuth. They're executing on behalf of us, the user, my credentials, so that I'm not able to get, I can make a lot of whatever MCP things I want to do under Mike rather than under Kalyani's. I can't get into Kalyani's email or something like that. But if we go back to some of the CISA principles, just this year, OAuth released their best practices guide that was several pages long. And, best practices is kind of synonymous with hardening. So are we getting any better, Jack? I know CISA has some opinions on hardening guides.
So yeah, that's another area that we addressed in the white paper is essentially this idea that we should flip hardening guides on the head, that it should instead be loosening guides, that the default configuration of a proxy should be a secure one. If users want to weaken that and make the conscious decision to use a less secure product, then they can go do that, but the default should be secure. So I think that, of course, progress takes time, and that we need to be careful, especially, again, thinking to this developer experience standpoint. Are we just giving more hardening guides in whatever kind of recantation that looks like to developers, and again, putting the burden on them to write secure code? Or are we moving to a model where, like React, like Let's Encrypt, the easy route is one that is secure? So I think that's something, particularly as companies are building their MCP servers or whatever kind of this next generation of tooling looks like, think about some of the lessons from decades of writing insecure software and figure out how to not repeat some of the same mistakes.
Yeah, so I can't resist. MCP was also the master control program, which was the bad guy in Tron. But as part of Tron, the reason I bring that up, one of the themes was fight for the user. So I think our theme is we're fighting for the user, as both what Kalyani and Jack are saying. Now, both of you were pointing out LLMs are there. They're assistants for coding. Have you seen them? And maybe Kalyani, you could start us off with this. Have they helped you with threat modeling, let alone is there any secure design assistance that LLMs are going to give us?
I haven't had great success with it, unfortunately. I don't think LLMs have been a great threat modeling assistant to me. I have started all kinds of prompts, like you are a master threat modeling expert, but it did not render me the kind of results I wanted it to render. And unfortunately, there's so many business logic flaws that it will miss out on. And then, well, don't even get me started on hallucinations. The number of times there has been like this weird sense of typo squatting, like these packages don't even exist. You're hallucinating big time and just generating names at this point. So, I mean, it's still nascent. I'm very hopeful though.
Okay.
Yeah.
What about you, Jack? I mean, you were saying you've seen all this tons of code. How do you fall on this?
Yeah. So I'd say that I'm also optimistic, and this is in part what we're trying to do, is leverage some of the upside and capabilities of LLMs to, combined with deterministic methods that we've used for securing products, historically to really be able to really, in a much more tailored way, assess the security of an application. So I agree that this is going to take time, that it's not like you can just say, hey, ChatGPT, secure my app, and it'll magically output a more secure version. But I do think that we are able to use them to find vulnerabilities like, say, authorization flaws that before it's really hard to say, okay, here's the like consistent way by which I will make sure I don't introduce a insecure direct object reference or some other vulnerability. LLMs can help with some aspects of discovery because they're able to parse the unstructured data, documentation, or other aspects of how the application operates and really digest that and help understand where you might be taking missteps. So it's an area where we think there's a lot of potential to not solve application security, but at least help companies who traditionally have been under-resourced, not able to take advantage of the state of the art and do a better job.
Yeah, so it sounds what I hear, and I'm going to be the pessimistic one on the panel for this, but it sounds like LLMs can maybe help us answer or ask those questions and perhaps answer in what could go wrong. Here's what could go wrong with authentication, or what could go wrong with me using this endpoint. Is there a command injection? Those seem targeted and maybe specific, but maybe they're just that's off of a WASP checklist. You know, that's good. But the LLM isn't giving us insight into, was this a good C program? And here I'll give the example of, like, I think curl, I would point to as a project that actually demonstrates good design through its practices, even though it's in C, but this also has a lot of burden because it is in C. The opposite would be something like OpenSSL, which is pretty messy. And I don't know that an LLM could help us analyze to say, why is one, if you all agree even, why is curl a good design and why is OpenSSL a bad design? I don't know. Does that resonate in any way?
And maybe in that case, even if you are able to take something like curl and reasonably secure it, maybe you should have just started in a language like Rust in the first place and not had to put in all this work in that.
I think, though, there is still the roadblock of context, right? I think, sure, it can give you a very generic answer maybe about how one framework might be better than another, but if it lacks context of what your application is or what your security culture is, I think it's a very tailor-made answer to you, which only you know, since you have hands-on experience with the tool. So yeah, I think
that's
context. Yeah.
That's a good. We're starting to have to wind down, and that's already a good takeaway message. Jack, what else would you give us as a takeaway on this topic of secure design and UX dragons?
Yeah. So I really would go back to some of the secure by design principles we had at CISA, right? Where again, that companies really need to be leading from the top, making sure that this is a priority from the executive leadership, that they're leading with radical transparency and accountability, and lastly, that they're really prioritizing customer security outcomes. And at the end of the day, I do think that the best way to get here is to combine some of these ideas. Think about the developer experience. Think about the fact that as much as I've advocated for change here, the vast majority of developers still don't learn much about security. So they're not going to be security experts. And particularly as AI is changing the definition of what it means to be a developer, making it so more and more people are able to write code, we can't rely on the people writing code to know how to secure it. So what are those secure guardrails we can put in place? As companies, how can they make sure that their developers are writing code that it conforms to their security best practices, make sure that they're using these secure patterns out of the gates. So really that's what I think company application security teams need to be thinking about.
I think that's a great message to end on. Thank you. Let's give Kalyani and Jack a round of applause. Also want to give a shout out to our crew behind the scenes. Tyson and Sam are here today. And shout out to Tom, Renee, and John back in our virtual studio. And thank you once again to B-Sides for bringing us all together. Please subscribe, check out the show notes, share us on the socials, and speaking of things that are dangerous, check out Death Racer by Carpenter Brute. We'll see you next time on Application Security Weekly.
All right, well done.
Thank you.
Awesome.
Let's get around, folks. Mike, Jack, Kalyani, thank you very much.